Hello students, in this lecture I will be talking about the different properties of some crystal structures. So as we know about the cubic crystal system, there are three types. One is simple cubic, then body centered and then face centered cubic. In the simple cubic structure, the atoms are located at each corner of the cube and the lattice constants are equal to each other and the interfacial angles are also equal to each other and are equal to 90 degree. Each corner atom is shared by 8 unit cell. So this corner atom is actually shared by 8 unit cells. So only 1 by 8 part of this volume of the atom is available for each unit cell. So as we can see here that one unit cell has 8 atoms and only 1 by 8 part of the volume of the atom is available to this unit cell. So the contribution from the atom to the cell will be only 1. So the effective number of the lattice point in a simple cubic structure is 1 and so it is also called primitive cell. Coming to the coordination number, so in a cubic structure there are 6 atoms which are closest to any atom. So for the atom at the center, there are 4 nearest neighbors in its own plane. So these are the 4 atoms. In this one. And then 2 atoms which is directly above and below it. So except these 6 atoms, all the atoms are from this central atom and so there are 6 neighbors and so the coordination number is 6. Now all the atoms in the corner touch each other. So if the lattice constant is A and radius of the atom is r, then the lattice constant will be equal to 2r and so the radius will be a by 2. Now we know that simple cubic cell structure has one atom per unit cell. Volume of the atom can be given by 4 by 3 pi r cube and volume of the cell is a cube and r we already know. So from all these values we can get the atomic packing factor for the simple cubic structure. So which comes 52%. So it means that 52% of the volume is occupied by atoms and the remaining 48% volume is vacant, which is called the void volume. Coming to the body center structure, so now here 8 atoms are in the corner and there is one atom in the center of the body. The lattice constants here are also equal and also the interfacial angles are equal and equal to 90 degree. But here the corner atoms do not touch each other. Rather, the corner atom touch to the body centered atom. So there is one unshared atom belongs to unit cell which is the body centered atom and one shared atom from the 8 corners and so the total number of atoms per unit cell is 2 for the body centered cubic structure. For the body centered cubic structure we can also call it BCC. The coordination number is 8. As we can see here, for the central atom there are 8 body center atoms close to this atom. So 1, 2, 3, 4, 5, 6, and 7, and 8. So these 8 body center atoms are closest to this center atom, and other atoms are far from this atom. So it has 8 closest neighbors, and so the coordination number is 8. Now, if we want to calculate the radius of the atom in the body centered cubic structure, then first we have to calculate the phase diagonal, which is here, then the body diagonal. Here this is the body diagonal, and then because the body center atom and the corner atom, the total length is 4r, so this 4r will be equal to under root 3a, and so the radius of the body centered atom will be r is equal to under root 3a by 4. So as you can see here, that body center atom touch the corner atoms, but corner atoms do not touch each other. Now, as we know the value of radius of the atoms for the BCC structure, so we can get the atomic packing factor for the BCC structure, which is 68%. It means that the 68% of the volume of the unit cell is occupied by the atoms, and the left 32% is vacant. Coming to the face-centered cubic structure, which is so-called FCC structure, so it has 8 atoms in the corner and 6 atoms in the center of the each face. Here also the lattice constants are equal, and so the interfacial angles and equal to 90 degree. Now here the corner atoms touch the face atoms, but it does not touch the corner atoms. So each face centered atom is shared by 2 unit cells. So total shared face centered atom which belongs to one cell will be 3, and the total corner atoms which will belong to one unit cell will be 1. So total number of atoms which will belong to one cell will be 4. Now from here we can see that the center atom is close to the face centered atoms, which are 12 in number. So as you can see here, in this plane there are 4 center atoms, then in this plane there are 4 face centered atoms, and then in this plane there are 4 more face centered atoms. So there are total 12 face centered atoms, which is closest to the central atom, and that is why the coordination number for the FCC structure is 12. Now to calculate the radius of the face centered atom, as you can see the lattice constant is A, and the face diagonal is equal to 4r, and also the face diagonal is equal to under 2a. So the radius of the atom will be a by 2 root 2. So from here, if we want to calculate the atomic packing factor, we will get 74%, which means the 74% of the volume of the unit cell is occupied by the atoms, and remaining 26% is vacant.